Hello, everyone. Thanks for joining us today for our Terraform Orchestration Summit. This session is part of an ongoing series where we highlight new and unique ways to automate and orchestrate infrastructure provisioning. If you want to view additional sessions, you can navigate to quali.com and go to the resource tab. You'll find some additional sessions on related topics that are we think you'll find very complementary to this session. My name is Brent. I'm in the product group at Quali Systems. I'm going to cover the housekeeping items and before we get started, and I'll field questions posed by the audience. We definitely try to keep these sessions focused and to the point. So we'll probably run 30, 35 minutes kind of thing. I promise, we're not going to slide whip you. We'll start with a brief overview, sort of the state of Terraform and infrastructure as code, cover off some of the challenges that we're seeing, and help navigate, managing and orchestrating, complex application environments. The bulk of the session will be hands-on keyboard. We're going to show you some unique capabilities in our platforms. And with that in mind, I'm joined by Tomer Adman. He's our field CTO, and he'll be leading the session. Say, hey, Tomer, nice to see you. Nice to have you with us.
Thank you, Brent. Great to be here.
Yeah. So hey, to get us started, I wanted to get your thoughts on something. Terraform is a very well-known and popular IAC technology, and some suggest it can easily contribute to the configuration sprawl. Is that something that we're seeing?
So I think that's a great segue to actually start the slides here. And really what I wanted to discuss is the current state, what we currently see in the market. And we are really working with a lot of our customers and other companies out there. Regardless, by the way, if it's Terraform or other IACs, different companies, different teams likes different tools. But what we really see is the demand from the end users. Everyone needs environments, right? So regardless if that's from an IT team, DevOps team, operations team, everyone needs something. It might be upgrades for the production environment, adding a new microservice or a new PaaS service to the environment. It might be a development environment. And eventually there are just numerous amount of requests, and then something happens, right? Someone needs to handle those requests. Someone needs to monitor who's using what's the current inventory, how much things cost us. And somewhere in there, it's getting into the cloud, into the on-premise environment, into our inventory. But what we really see is this sprawl of mess, really. So the end result is really slow processes. So someone is asking for a development environment. It might take from a few days to a few weeks. In some customers, in some companies out there, we see 5 weeks to get a development environment. And honestly, it's just chaotic, right? It's a waste of time. People are just waiting. And on the other hand, the people that need to provide the infrastructure are usually just on a pause. It's hard. It's full of bottlenecks, and it's really hard because there is no visibility to what's running and what's not. And what we really wanted to discuss in this webinar is how Quali and in general, how we see a few solutions to that. So again, we're talking about some user out there that needs some environment, right? It starts from, I need to do something for the business, regardless if that's a QA engineer that needs environment for testing, performance testing, a developer that needs to develop, or someone that needs to roll out the change to production. Someone needs environment. Someone needs to interact with an environment. Now, those environments, let's try to keep it abstract, are somewhere, they are being managed, they are maybe provisioned on demand, and they're the gateway to the clouds, to the infrastructure, to the different services. Now, what Quali really likes to talk about is application environments. Take everything you need in order to model that environment from the infrastructure, application, and data point of view, but also add all the testing equipment, add the monitoring aspects, add the logging aspects, everything you need in order to fulfill something for the business. So with that, just keep in mind that environments are all around us. We need them in order to progress with our software development lifecycle. And regardless of the technologies themselves, it might be on-premise virtualization, it might be serverless in the cloud or cloud native applications running maybe on Kubernetes, or even edge technologies. we all need the environment. That's the basic dependency in order to develop something, in order to test something, in order to secure something, and eventually in order to get that into production and see some dollars coming back to the business. So with that, the question is how we really build those application environment. And what I'm going to really talk about today is how Torgue, our SaaS offering, is doing that. And that's really using 4 steps. So first of all, we need to discover the infrastructure. We need to understand what are the automation tools or automation assets a specific company is using. It might be different components, maybe Terraform and Helm, or Pulumi and CloudFormation. Different teams might use different technologies and different standardization. And we need to discover those, right? We need to take those as kind of a building block, normalize them, and then build out of that a meaningful environment that will fulfill the business need. It might be building a database, then building the front end, back end, connecting between them, making sure everything is secure, and then exposing that to the end user that needs that for something. It might be rolling out something to production. Now, eventually, the last step is really to make sure that we are measuring everything. We know who is using what, why, get visibility to all the environments that are running. And honestly, one of the more interesting questions I'm usually asking out there in the field is how many environments do you have? And sometimes IT managers, DevOps managers are really not sure about that because there are so many environments, so many things that are unmanaged. And using this approach, we can start gather those resources, cloud resources, processes into something meaningful in a form of an application environment. Now, what's really important to say is that we are really focusing on rapid time to value. So all of those 4 steps, from seconds to maximum 1 week, you're getting all of your environment modeled using your existing automation tools. You can launch your environment repeatedly in a stable way, in a managed way, and then about a week later, you can get the actual usage report, which is not only consumption, but also cost related. And that's really important because for sure, if you're deploying in the cloud, if you're doing multi-cloud, you want to see the different components, how much they cost in different clouds. Maybe you want to compare between the different clouds. So the tool will really bring everything into you in a very simple way to get this visibility. So just for quick summary, before I'm moving on to the demo, what we really want to show in this demo is how Quali is different than the day-to-day or the current state that we see out there. We want to provide something that utilizes the existing automation in companies are already using. So you don't need to invest in another automation tool. We take your existing automation assets and we discover them. We provide them as standardized building blocks for you to build whatever you need. Everything is going to be unified within this control plane notion. So you can build in different environments, add governance, standardization features using heterogeneous infrastructure using those building blocks. Now we provide the usage based on the business value and the business need. So, and I'm going to talk about it pretty soon about how we add the business layer on top of the running environments. We provide visibility to everything, not only to the assets, the automation assets that were used or the environment, but also to the actual infrastructure that was deployed in the cloud or on-premise. And eventually, we are also adding a lot of governance, security, and compliance features that help really secure everything around those environments. Maybe the production environments needs to be set with a specific compliance configuration, so we can add that in an automated way and make sure it's impossible to breach that. So with that, I'm really suggesting you all to join our trial. So feel free to join now. You can follow me in this during the demo and see what's possible. And without any more slides, I'm just going to jump right into the demo. Brent, if you have anything to add, please do.
We're good for now. But for the audience, if you want to pose a question, you can do that with the Q&A button or pop it in the chat, and we'll get that to Tomer. Thanks, Tomer.
Awesome. So what you see here is Torgue. Just going to zoom in a bit. Torgue is one of the offerings by Quali. It's a SaaS platform. We do have other ways to deploy that for more secure networks, but this is the SaaS platform. You can just register, get your account, and start rolling. And what I'm going to talk about first is the end user catalog. So we discussed those users that needs something, right? They have a task today to build something, to test something, and what they need is an environment. Now, usually the DevOps or IT teams will have a set of predefined configurations that are built some way in some place, maybe Jenkins or other CI tools. Now, in this catalog, you don't really need any other tool, and the user can get the environment in a self-service way. So let's just pick one environment out of this pretty rich catalog. By the way, this catalog was specifically designed by our DevOps team for our users within Quali. And let's just launch this web game. And as you can see, I'm requested to fill in for how much time I need this environment. In this case, I'm going to take the environment for 2 hours. But just to make sure, or just to emphasize, these environments can be time-based. It means that everything that we're building will be destroyed within 2 hours. So think about the number of cloud resources that you have right now that are not being managed. You're not sure who's using them. All of that can be really reduced significantly. And we see that as a huge ROI with most of our customers, because every environment has a specific purpose for a specific period of time. Obviously, we have environments like staging and production that will be timeless or always on, and that's obviously also possible in the tool. So I've just launched a new environment. You can see that this environment graph is kind of describing what will be deployed. And in this case, we have 2 different Terraform modules. We like to call them DevOps microservices. So we have KMS key and S3 web app module. These modules were actually built by different teams. So the KMS key was built by our security team, and the S3 web app was built by the application team. Now, taking those smaller microservices that are really easy to manage and being managed by different teams and combine them together, kind of gluing this into one single business process is really helping us, because every team can really focus on their own task, but still the end user can get whatever they need. Now, the deployment process is in progress. You can see all the steps here. You can obviously see all the logs and everything. Terraform is being executed in a centralized place. And once the deployment will end, it's not only that we have a new available standard environment, but we also have visibility to what was deployed. So we're going to wait for an extra second for the deployment process to finish. And then I'm going to show you a bunch of interesting features on top of that. Now, until then, what I can say is that everything that we are deploying is being tagged in an automated way using this extra level of business context. Regardless if you're using Terraform or other IACs, it's really hard to make sure that everything is tagged in a standard way. Usually, we see very long projects where DevOps teams need to re-tag or re-edit all of their modules in order to add specific tags. In Torgue, you can actually manage that in a centralized place, and then everything will be automatically tagged. So in this case, we have 2 different modules. We deployed, or out of those 2 different modules, 8 different cloud resources were deployed. Here is the bucket as an example. And this bucket and the other 8 cloud resources were automatically tagged with all of those tags that were configured in a centralized place. Now, those tags are really the extra level of business context about who deployed the environment, why it was deployed for, what was the original configuration, who is allocated for the cost, and more and more. We see customers adding a lot of different tags here and eventually implementing the tagging methodology of the organization within Torgue in a centralized place, and then everything is deployed, regardless, by the way, of the ISC technology. So if we are doing Kubernetes orchestration, for example, using Helm or Kubernetes manifests, the tagging will be labels. So everything eventually is standardized. So you saw that the two different modules are now deployed. You see that the end user get direct access to the application. It's now deployed on S3 as a single page application in AWS. And you already saw all of the resources and the information about them. So the bucket, for example, you can see here the ARN, the different tags, the ID of the bucket, and more and more. So it's not only the orchestration layer, but also the cloud resources layer. Moving to something a little bit more interesting, let's take a look at that kind of a multi-component environment. And this is really where things get tricky. In the real world, it will be pretty hard to orchestrate different tools. You will need to build your own pipeline for that, or basically your own orchestrator in order to make sure you have the infrastructure, the application, and the data all in one place. In this example, you can see two different Terraform modules for building the infrastructure of the environment, and a Helm chart that was deployed in order to build the microservice application. Now, a dependency was set because it's impossible to deploy the microservices without the infrastructure. So Torque really allows you to take those infrastructure blocks, regardless of the technology, and merging them together, tracking the cost, allocating or orchestrating those as environments, and then get visibility to all of the running environments we have under a specific organization. Now, we've talked about discovery, so I really wanted to present that for a second. And I'm going to move to a different team here. Torque, by the way, provides different spaces for different teams or different projects. And you see here, I have a GitHub repository. I'm just going to click on discovery. So Torque connects to that GitHub repository, looks around and looking for different ISC technologies. And you can see here that we have Terraform modules that we found, Helm chart, Kubernetes manifest, and cloud formations. Let's just pick one of them, and let's take this KMS key we've kind of already discussed. And what Torque provides, regardless of the discovery that was already made, it is actually normalizing the automation framework. And now we have a way to just deploy it. So around 30 seconds, 2 clicks, and now I can deploy this KMS key in a centralized and managed way. That's all I need to do. Now, what you can see here, by the way, is the Torque manifests that describes what needs to be set in order to launch this Terraform module, what are the configurations, and what will be the output of this Terraform module to the user when the environment will be managed. So everything was done for me by the tool. I don't need to do anything. And if I want to kind of compose different building blocks together, I can do that in here using this YAML editor, or I can do this directly from my IDE and then use a GitHub approach in order to save it, have pull requests, branches, and more and more. Let's take a look at something that we see very common. So companies have a Terraform module that is kind of a monolith deployment. It's really hard to enable that to end user because this virtual machine module is actually hiding a lot of complexity around networking, and somewhere in there is a virtual machine. So what we looked for, or what a lot of our customers is looking for, is another view, another layout of this environment, so the end user will be able to use this in a meaningful way, something that will be something that will make sense for them. So it's definitely not the Terraform module, right? Because they're not, maybe they don't even know what Terraform is. What they want to see is the actual resource that they care about. So I'm just going to click on resources layout. And now you can see that instead of seeing the DevOps view or the Terraform view, you can see the virtual machine itself. And on this virtual machine, that was the only virtual machine that will deploy within that Terraform module that deploys other things. But here you can see the OS, you can see the state of the VM, you can see the IP, and by the way, all the other attributes like the user, the passwords, and more. But we're not only providing the visibility for the end user to see the meaningful components within the environment, we can also enable him with day-to actions, like let's say he wants to power off or restart the VM. So now the DevOps or IT engineers doesn't need to do anything. Everything is in the hand of the end user. And that's really helping to streamline not just environments, but really to reduce the number of tickets, empowering the end users, and provide a really frictionless approach to environments. So that was another interesting aspect. And the last environment I'm going to show is really around security. So from time to time, you want to launch an environment, but before you're launching the actual resources, you want to go through governance and compliance protocols. In this environment, what you can see is that before we deploy something into Kubernetes cluster, this portal deployment, we actually executed a bunch of validations. In this example, it's the tree and kubescape, and those deployments actually went through the manifest that are about to be deployed and tested for known vulnerabilities and misconfigurations. So it's not only that you can take those ISC assets you already have, model them as building blocks, you can actually take scripts, Python protocols, PowerShell, whatever you already have out there in the organization, built, maintained by different teams, you can now take that and glue that together into something that will be meaningful. Now, an environment won't be ready for the end user if the networking aspect is not ready. So in this example, we tested the manifest, we deployed the manifest, but since this is deployed in the cloud, the fact that we deploy the manifest doesn't mean the environment is ready for the end user. So we've added a health check that will wait for, in this case, an ELB in AWS to be ready for the end user to be able to access the environment. Again, we have the application exposed here with the architecture diagram for the end user. So everything is really easy for him, not just to access, but also to understand the infrastructure and the logic behind the scenes. The resources, by the way, here will be the Kubernetes resources and not the infrastructure resources, because this is just a Kubernetes deployment. Great. So we've talked about how we are managing environment, the concept of environment. We saw how we get visibility to environment and how everything is standardized. I want to talk a little bit about the management aspect of things, and I'm going to start with policies. Now, policies is kind of tricky because when we are launching environment, when we are managing environments, we want to empower our end user, but we want to make sure we are doing that very cautiously, right? We want to make sure they're able to do just the right amount of things. Let's say someone wants to deploy a Terraform module out of the community. We want to make sure that doesn't breach compliance or security, or no one leaves maybe a blob storage in Azure or an S3 bucket public in AWS. So what we can do is we can add or apply one of our existing out-of-the-box policies into Torgue. And let's say in Azure, we want to define the allowed locations, only a number of allowed locations that will be okay for the company to deploy in. And applying this policy basically means that any deployment to Azure that doesn't meet one of those locations will be automatically blocked. Now, let's take a look at that for a second. Let's go back to one of the environment we already saw, and you can see here a step called plan validation. So every time we are running a deployment for a specific building block, we are basically revalidating all of the different policies, all of the different rules in order to make sure that this deployment is valid and it's approved according to all of the different standards in the organization. Now, a very interesting part, and I'm going to delete this for now, but a very important part here is that everything is as code. The blueprints are as code, the infrastructure is as code, and the policies are as code as well. So we are utilizing OPA, Open Policy Agent, and this is basically helps us to be everything as code. So environment as code. OPA can define different policies from Terraform to Kubernetes to CloudFormation, but also we have Torgue policies specifically. So we've integrated with OPA, and what you can get out of that is policies that are specifically for a specific environment. Let's say you want to launch an environment with a maximum duration of X amount of time, or you want to invoke an approval flow if something breaches specific cost amount. Everything is possible using this as code notion for policies. Lastly, what I'm going to talk about is the reporting capabilities. And this is something we are getting out of the standardized tagging. Regardless of the cloud, regardless of the automation framework, we are tagging everything. Then we are grabbing the resource information using those tags from the cloud or from Kubernetes clusters. And then we can basically get visibility to what was deployed and the business context around it. Now, the business context is really important together with the cost information. So you can see here, for example, this AWS account or this Azure subscription, how much it cost us so far in this month, what will be the forecast for this month. And we can see different breakdowns of the information. You can see here, for example, our live space. So our production group, they're called live. They spend this amount of money this month. The developers use this amount of money, the staging, etc., etc. So the reporting capabilities is really closing this story around modeling environments, visibility to environment, managing environment, tearing down environment, day 2 of environment, and then getting this business context around it. Now, before we will move on to a few questions, I just want to say that environment as a service, or this tool, Torgue, is really around managing those environments, right? And maybe you currently have those environments managed in different ways, maybe using a pipeline in Jenkins, maybe using scripts, maybe someone is doing that manually. And what's important to understand is that this type of platform really enables the environment to the entire organization. Might be a finance group, might be the IT group themselves that want to increase velocity when building environments according to ITSM tickets, right? But the power here is that this platform can be integrated to other systems in the organization to really speed up things. So we can integrate with ChatOps systems in order to get quick notifications about environment changes. We can invoke environments from Slack or Teams, for example. You can automatically invoke environments from ITSM tools like Zendesk, ServiceNow, BMC Remedy. We can integrate with CI/CD system in order to roll out changes, in order to invoke environments for automation tests, so like Circle CI, Jenkins, Bamboo, Azure DevOps, and more and more. And eventually, what you see is that the logic of how you manage, how you orchestrate the environment goes out from those systems into a centralized place, which is Torgue. Everything is audited, everything is logged, and everything is role-based access control. And all of those other systems can now integrate with Torgue to invoke, to change, to ask for environment details. And that really helps scale up the DevOps or IT team and really do more with much less. So with that, Brent, do we have any questions?
Actually, we do, Tomer. Got a couple. This one's interesting. You kind of touched on this a little bit. I'll paraphrase the question. The question goes something like, we have hundreds of Terraform scripts. Many of them are legacy, created by people who no longer work in the organization. We don't even understand what they're defining. So one question is, are there any limitations for bringing in those scripts? And how long does it take to get them into Torgue? Can you comment on that?
Great. So as we kind of discussed, the discovery process is super fast. You're just connecting your repository. It might be Azure DevOps, it might be Bitbucket, GitLab, or GitHub. And we, by the way, support the on-premise versions as well. And once connected, Torgue will go through everything and discover everything that we support. And it might be super legacy, it might be the newest and greatest technologies and assets that company is doing. But what's important is that Torque is taking those, normalizing those to be building blocks. So it might be a legacy Terraform module that was built a few years ago using a very old Terraform version. Torque will understand that, set that version, create a small building block for that. And from that moment on, you can just reuse it in different places. So it should be pretty easy to utilize those and use them again, or to revive them. And by the way, it's very interesting that once you have a blueprint with several different building blocks, you can then start a modernization process on the building block level to change the technology or rebuild some of the modules. We see that with customers that are doing just Terraform, and then they want to move to maybe Crossplane or something that will be more native or specific cloud. And then what we see is that they are gradually moving specific building block to the new technology, and the blueprints themselves, the end user service, the experience, everything stays the same. So you can still launch environment. The environment you launch are still up and running and fully managed. Everything is standardized, but you have the opportunity to do the modernization process specifically per building block.
Great, thanks. The second question you kind of answered, but I'll ask it again just because of the audience submitting it. We have a need to combine configurations from multiple tools, and that feels like it's something that Torque supports natively. Do you want to comment on that a little more?
Sure. So Torque supports natively a lot of different IACs, container orchestration and configuration management systems. We want to keep this microservice approach, or this discovery building block approach. So we see a lot of customers that are doing Terraform to launch the infrastructure and then Ansible to configure maybe VMs, or we see teams that are doing scripts and then launching a pipeline and then at the end running some validation. So we have a lot of different tools, a lot of different use cases, but what's really important is to take those automation parts, we call them islands of automation, take those automation parts, really connect them into one story that's meaningful for the business. And this is possible using the Torque manifest, the YAML file, and those building blocks. So you can do anything that we support, which is pretty impressive set of IACs. In this example, again, you can see Terraform and Helm. And with Terraform, we'll do the infrastructure, Helm will be the application deployment, and we provide all of those amazing capabilities on top of the running environment.
Great. Thanks, Tomer. So very insightful session, Tomer. Really appreciate you taking the time. I'm sure the audience got a lot out of this. And thanks to all of you, the audience, for joining us today. We really appreciate you taking time out of your day to join us. Just a reminder, there will be a recording of this session posted to the URL where you registered and available on Quali.com. So if you have colleagues that might benefit from this, by all means, please encourage them to view the recording. And again, you can request a trial of Torque. We'd gladly get you set up and started there. Just go to Quali.com/request a trial. And we'll very much encourage you to do that. And you can take your own time and explore the tool and understand how it could best address your challenges around Terraform and IAC in general. So with that, we'll shut the session down. And again, thank you and enjoy the rest of your day.